was okay with number one, I hope, right? You should all be able to take expressions and turn them into variable expressions. English to math, right? English to math. Or we should say, language to math. In this case, English to math. The number decreased by 4, x minus 4, right? We all understand that? Any other questions? Let's jump to the homework. Because I'm going to go over some of the homework together with you guys. Okay? Other questions on stuff that you read or watched in the video? Yeah?
Maybe example 6.
Example 6.
Yeah,
Okay. So a train leaves town traveling 50 kilometers an hour going east. 3 hours later, another train leaves town traveling 75 kilometers east. How long will it take the second train to catch up to the first train? There are several ways to do this. You could plot it out and look at the distance traveled. You could say, all right, in 3 hours, this person got a head start. How much is this train catching up by every hour? That's one way to do it. Or you could find the distance formula for each and say, well, when will they be caught up to each other? When they're at the same distance. Set them equal to each other. So there are 2 ways to do this problem. I'll show you both ways, just for now. So object number 1, a train leaves town at 50 kilometers an hour. So this person's distance is going to be 50 kilometers an hour after X hours have occurred. Okay, that's the first person. Distance equals rate times time. The second train travels some distance, but at 75 kilometers an hour. But how many hours have gone by? In terms of X, how many hours have gone by? Why? Yeah, so if the first train has been traveling for 7 hours, the second train has only been traveling for 4 hours. If this first train has been traveling 10 hours, the second train, 7 hours. How do you get that? X minus 3 is what you get. Now, when will the trains be literally next to each other? When they've traveled the same distance. So these distances are identical. So although you might call this D1 and you might call this D2 mathematically, D1 is equivalent to D2. So you could set them equal.
I had them as A, B, and C.
Fine. Yeah. And then solve. Okay? And then solve. Again, how long will it take the second train to catch up? You're going to solve for X. X will give you the total time since the first train went. You're going to subtract 3 from that to get the time for the second train. Remember, SAT question, the answer is not X. The answer you're looking for is X minus 3. Read what it says. How long will it take the second train to catch up? So although you're going to solve for X, you need to take away 3 to see how long the second train has been going for afterward. Okay? So what do you get as an answer for this? I'm curious. What was X? What did X turn out to be? X turned out to be 9. So the second train had been traveling for 6 hours as a result. Is that correct? Or was it 12 and then 9? So X would turn out to be 12 in this case then. Thank you.
And then minus 3 is 9.
So then it takes the second train 9 hours to catch up. Let me show you another way to do this. That way is the way to do it algebraically. Let me show you a way to do this with a quick picture. Here's train 1. It gets 3-hour head start. How far has it traveled in 3 hours? How far?
150.
Why? How come?
Because it's traveling 50 kilometers an hour.
Kilometers, my bad. Kilometers. Yes. Kilometers per hour. Very good. So 150 kilometers. All right. Now, where's the second train at this point? Second train is sitting back at base. So the first train got a head start. So how much distance is the second train going to have to cover when it catches up? 150 kilometers. It's got to cover an extra 150 kilometers to catch up. How much faster is it going?
25 kilometers.
How many?
25 kilometers per hour.
25 kilometers per hour faster than the other train?
I kind of see it.
If you take 150, so you sure the answer was 12 and 9, not 9 and 6?
I think so.
I think it was 9 and 6. I think I had it right the first time.
Yeah, I thought it was 6.
Right?
Yeah.
Because the answer I'm going to get here is going to be 6, Bridge. So go back to here. This would have been 9, I think. And this would have been 6, okay?
Yeah, that's right.
So if you do this, think about it. You're trying to cover 150 kilometers, and you're gaining, at every hour, you're gaining 25 kilometers. And you could visualize this. If one person walks with a velocity of 1 meter per second, right? Like this. And then the other person starts afterward. But the other person starts moving at like 3 meters per second or feet per second. Eventually, this is what's going to happen. Ready? This one's moving slowly. Catching up, catching up, catching up, catching up, catching up. Boom. They caught up. It has covered the gap of 150 kilometers. And how do I get this number? I just subtract the rates. If one is moving at 50, the other is moving at 75, that means that the one that's moving faster is gaining at this rate. It's gaining 25 kilometers every hour that occurs. So 150 kilometers, how many hours occur? 6 hours occur. Yes?
On a test, like, would you expect either method?
Yeah, but you need explanations for stuff. So I would like you to explain it. Obviously, you're not just going to put 6 as an answer and that's it.
Yeah.
So a diagram, explanations with words. If you're ever not going to use algebra, an algebraic method, you need to justify your answer with some sort of reasoning. And that needs to be a rational type of reasoning. You know what I mean? It has to have some context and some real content to it that makes sense by rational. I don't mean rational, let's irrational.
So you allow like using actual numbers instead of the algebra if we explain why we didn't.
If you're able to get to the answer with a clear explanation and it makes sense and you use a different approach, that's fine with me. But just guessing or saying the answer is 6, because I did it in my head, I want what you did in your head. Tell me what you did in your head. Okay? Explain in words that, okay, you know what? The first train was ahead by 150 after 3 hours. It's gaining 25 kilometers every hour. Therefore, after 6 hours, it will cover the 150 kilometers. That would be a great statement for exactly what you're seeing, which is literally no words here, right? Other questions? By the way, 1.9 is quite similar to 1.8. 1.8 was really like setting up problems, except this one was solved. 1.9 is almost the same topic, but now you're making sure to solve all of the problems that you didn't just set up. You're not just setting up expressions. Everybody, I hope, you decide to go for a jog from your house and run south on Park Ave at 8 miles an hour. An hour later, your brother also left home to go for a jog, but runs north at 6 miles an hour. How far apart are you how far apart are you after W hours have gone by since you left home? So which way are you running? In the same direction, opposite directions, toward each other, parallel to one another? Opposite directions. Who starts first? You do. How far do you go in that first hour? 8 miles. How do you know you go 8 miles in an hour? Hannah, you're the runner here. What's your speed in this case? 8 miles per hour. That means you literally travel 8 miles in an hour. Okay, so we go 8 miles. So here you are, right here. You're at school or you're at your house. You jog north on Park Avenue. You end up here after an hour, a distance of 8 miles. Now, at that instant in time, your brother or sister, in case you have either one of them, decides to leave home and go south. I'm sorry. Oh, you ran south. So let's say initially we ran south instead. Your brother or sister runs north on Park Avenue at 6 miles an hour. Okay? So after 1 hour, the distance between you is 8 miles. Your brother or sister is still at home, you are here. After 2 hours, your brother will be 6 miles from here because he has delayed the first hour. You have gone 8 miles and another 8 miles after 2 hours. So after 2 hours, your brother is here, but you now are down here. Another 8 miles have occurred because 2 hours have gone by. So the blue line is an hour behind the red line. Does that make sense? Okay. So the question is, how far apart are you W hours after you've gone home? So after 2 hours, you would just do 8 times 2 and get 16 for this. And up here you would do 6 times 2, but you'd have to subtract another 6, wouldn't you? You have to subtract one of those hours. So if I want to figure out how far you have traveled after 3 hours, 8 times 3. After 4 hours, 8 times 4. 5 hours, 8 times 5. Is that agreeable so far? So, as a result, your distance traveled will always be 8 times however many hours have gone by. If 2 hours go by, the answer is 16. If 3 hours go by, the answer is 24. But your brother waited an hour. He waited a full hour. So his rate is still 6 miles an hour, but how many hours have occurred? Have W hours occurred?
No,
How many hours?
W minus 1.
W minus 1 hours. Meaning, the same amount of hours you've traveled for, take away 1, that's how long he's been traveling. Now, every hour that occurs, the gap is spreading. The gap is spreading. So right now, after 2 hours, what's the gap? After 2 hours, what's the gap? What is it? 22. So what did you do to these numbers? 16 and 6, you added them. So take the expressions, sum them together. Distribute the 6, obviously, to both terms there. 6w minus 6 plus 8w is going to give you 14w minus 6. What is 14, the significance of this number? The significance of the number 14.
It's the rate in which they're running into the
Yeah, it's the rate at which they're separating. You're going 8 miles an hour, he's going 6 miles an hour, so every hour you're spreading by another 14 miles. That's the 14. Why minus 6?
Because since your brother's behind an hour.
Your brother's behind an hour, so he didn't cover those first 6 miles. Very good. Very good. Okay, the significance of your answer is extremely important. The significance of your answer. Understanding what it actually means. Other questions on the notes? Yeah, Hannah.
For example, 5.
Yeah, example 5.
So here's what I want you to do. There are 5 homework problems right now in section 1A, and there's some review ones you can do. I want you with the person near you, it could be the person next to you, we could do, let's do ladies here, gentlemen, and ladies here. Okay? Work on these problems with the person next to you. There are 5 textbooks right there. There are 10 of you, so textbook per group, or you can use your iPad with the book. Either way is fine. Go to chapter 1 on your iPad, that works. You're doing this homework at the end of this. You're still submitting this homework. Is that clear? But we're doing it in class. When you're done with the problem, I want you to check your answer with me. So in the back of the book, if it's odd, you can check the number. So if your number's right, the same in the back of the book, the answers are all there for the odd. Okay? So you can check the odd numbers. Are they all odd? No, one of them's not. If you don't get it right, call me over, go over with me. Okay? But I want to make sure you get all these and understand them all. Then move on to 1-7 and get the review ones done. That make sense? Okay? Over the weekend, we're going to do the same approach. We're going to take this whole chapter as this approach, or this whole section before the next test. Over the weekend, you're going to watch 1-9. You're going to come in on Monday. We're going to go over the 1-9 topics, ask for any questions on it, and then jump right into the homework questions. Does that make sense? That's why this is called a flipped classroom model. Just to kind of vary things. Instead of doing a lecture every single day, it gets boring after a while, okay? I'd rather you work with each other a little bit and talk amongst each other. If you need a text, go ahead and grab one or use the iPad. It doesn't matter. If everybody finishes and we have a lot of time left, maybe I'll continue with the project and give you guys a little more leeway so you can get actually started on it. Because you still can't really start the project yet. We have to do a little more background still.